Sufficiency or sufficient estimator is on our next property of an good estimator. We have already discussed about mean square error, unbiasedness and consistency. So we discuss first about an sufficient estimator, then we discuss about the method to find sufficient estimator. So an estimator based on a sample of size n. We take sample from a population with unknown parameter theta of size n, and this is our an estimator based on the sample of size n is said to be sufficient estimator. This estimator T is called sufficient estimator of parameter theta if it contains all the information about the parameter theta in the given sample. That means whatever the information given by the sample is contained in the estimator T, then it is called sufficient estimator for theta. Or there is another approach to find or definition of a sufficient estimator. It is based on the conditional distribution. The estimator T is said to be sufficient estimator of parameter theta from the population with the density fx theta. That means the sample taken from the population with density fx theta. If the conditional distribution of the sample observation given T, that means probability of x1 takes value x1, small x1, x2 takes some value say small x2, and xn takes some value small xn, given the statistic T takes value, let's say k, is independent of theta. When you find this probability distribution, this probability function, conditional probability, if it depends on theta, then it is called ancillary statistic. We discuss about it in later section. If it is independent of theta, then we say that the estimator T is sufficient estimator of theta. This is the first approach to find the sufficient estimator of a unknown parameter. We have given the distribution function. We take sample of size n. We have the values of the sample observation. Then we simply find this probability density function. Sometimes it's very typical to find this probability. So is the another approach called Neyman factorization theorem. So by which we can easily find the sufficient estimator of any parameter. Problem based on conditional approach. रैंडम सैंपल दे रखा है बर्नौली पॉपुलेशन से विद पैरामीटर P. You have to show that the sum of Bernoulli variate is sufficient estimator for parameter P. This is result from discrete distribution. If xi are Bernoulli population, Bernoulli random variable, then xi takes two value. Xi takes two value 0 and 1. When it takes value 1, then its probability is P. If it takes value 0, its probability is 1 minus. This is another important result. The sum of n Bernoulli variates represent binomial distribution with parameter n and p. So its value, if t takes value t, then probability of t takes, let's say t takes value k, then its probability is p की power k 1 minus. This is the distribution function of binomial distribution. Now we have to find this estimator as sufficient estimator for parameter t. So we find conditional distribution of x1, x2, xn takes value small n, given that t takes value k. If this value depends on p, then t cannot be sufficient for p. If it is free from value parameter p, then t is called sufficient estimator. So the formula for the conditional probability is एक बी और ए इंटरसेक्शन बी कैसे भी रिप्रेजेंट कर सकते हैं डिवाइडेड बाय द वैल्यू ऑफ दिस प्रोबेबिलिटी. सो इट टेक्स वैल्यू so it takes an intersection, or simply you can write it as xn intersection t takes value k. These are two events. First one is this, then second one is this, divided by probability of t takes value k. Now we know that this probability from this equation, and we can find this probability by using an important result. If A is subset of B, then probability of A intersection B is simply probability of A. Since A intersection B becomes intersection of A, here is also all the elements in this event. Since t takes value, what t takes value? T value is sigma x, summation of xi. Since xi takes value 0 and 1, so t takes value from 0 to either it can take value 0, 1, 2, or maximum value it can take is n, when all the xi takes value 1. So whatever be the value taken by x1 xi takes value 0, 1. Whatever be the value takes by xi, it is always subset of the value taken by the event or random variable t. So this event is x2 xn is subset of t. So subset of t implies that probability of, or in notation of intersection x2, we can take between two events comma or intersection, both are the same representation, intersection t, simply this value. Since all the value taken by this event are subset of the value taken by t, so it is simply this event. So this probability becomes, तो हम इसको ऐसे लिख सकते हैं, x1 x2 takes value और xn takes value xn divided by t takes value a. Now since the Bernoulli events are independent, so the probability of their intersection is separate probability of happening of their events. So there is another result. If events A, V are independent, then their probability are simply this. तो इसका रिजल्ट, इसका यूज क्या ये आ गया, और इसका यूज क्या इस रिजल्ट का यूज किया तो ये ऊपर की प्रोबेबिलिटी आ गई. प्रोबेबिलिटी मास फंक्शन फॉर बर्नौली पॉपुलेशन इज, इफ x takes value xi, then its mass function is xi 1 minus p की power 1 minus xi. So for first variable it becomes x1 1 minus x1. For second variable x2 it becomes, similarly for nth variable it becomes one minus x, and divided by, we put the probability of this event from equation, this one equation, so it is combination represent phi k 1 minus p n minus k, where k is summation of x. Now if we multiply this, the power of p becomes x1 plus x2 plus xn, so it is summation of xi, and the power of 1 minus p becomes 1 plus 1 plus 1, n times 1 add होगा तो n minus x1 plus x2 plus xn, so it becomes x I from 1 to n, I from 1 to n divided by, now we can put summation xi as k, these are cancel out, so it is free from 1 by free from parameter. That means T is sufficient estimator for event for parameter P. Next question on sufficiency by conditional approach. We have given x1, x2, x3 as a Bernoulli IID random variables, and we have given the statistic t, x1 plus 2x2 plus 3x3. Then we have to show t is sufficient or not. Okay, since x1, x2, x3 are IID Bernoulli, so x1, x2, x3 can take value 0 and 1. So we can take value from 0 to 0, 1, can get 2, 3, can get 4, 3, 2, 1, and 5 and 6. This is the range of values of t. So if we take value, particular value of t, say t is 3, then the combination of the samples such that t comes to be 3 is x1, x2, x3 takes value when it comes out to be 3, when x1, x2 0 and x3 comes out to be 1, and the other case when x3 is 0, x1, x2 are 1. There are only 2 cases when t comes out to be 3. So now we have to find the conditional probability of such that t takes value. The probability mass of PMF of Bernoulli variate is fx theta is theta to x 1 minus theta to 1 minus x, where x 1 or 2, theta lies between 0 and 1. So solve it, it comes out to be probability of t comes out to be 3, and the probability of x1, x2, x3 such that t is 3. Now we put the combination. Let's say x1, x2, x3 equal to 0, 0, 1. or we also take it as 110. इसमें कैलकुलेशन ईजी रहेगी, सो वी टेक 001 और इसको स्केप कर देंगे तो प्रोबेबिलिटी ऑफ x1 takes value 0 again, since these value taken by x1, x2 and x3 are subset of the statistic t, so and probability when t takes value 3, so t takes value 3 when x1 is 0, x2 is 0 and 1, and probability of, there are only two cases when, so the exhaustive number of cases and these are favorable number of cases. So this is probability, definition of probability. So favorable number of cases when x1 0, x2 0 and x3 1. So since x1, x2 and x3 are IID, so we can write it as similar to the last one question, divided by, again they are IID, into x3. So now we have the PDF of PMF. So we put the value of x for first x0 theta की power 0, 1 minus theta की power 1 minus 0, so it comes out to be 1 minus theta. Same comes out for x2 and for x3 1, so is 1 minus 1 0, it comes out to be theta divided by, this is the same value 1 minus theta theta plus for this value, so for x equal to 1 it comes out theta, and for this value it comes out to be 1 minus theta 1 minus theta whole square divided by theta 1 minus theta whole square, theta square 1 minus theta cancel, 1 minus theta cancel, so it comes out to be 1 minus theta divided by 1 minus theta plus theta, so which depends on the parameter. Hence T is not sufficient estimator for parameter